This is the third set of notes in the Weather and Atmosphere unit. It's called ES 11.3, Wind and Clouds. Global air circulation. Uneven heating of the Earth's surface creates areas of low and high pressure. Sunlight strikes the equator most directly and the poles at a very small angle. Warm air begins to rise through the process of convection. Warm air rises because it is less dense, while cool air sinks because it is denser. This convection in the atmosphere is a major driver of weather. Wind always flows from high to low pressure. So if the Earth were not rotating, warm air would rise near the equator, where there's low pressure, and cold air would sink at the poles, where there is high pressure. So the most solar radiation is hitting the Earth at the equator. The least solar radiation is hitting the Earth at the poles. That makes air warmer at the equator, so it rises. That's low pressure. And it makes high pressure at the poles, where air is colder and sinking. And if the Earth weren't spinning, there would just be this cycle that you see in the diagram. The spinning of the Earth creates a complex yet predictable pattern of global wind belts. Wind at the equator moves from east to west. These are called the trade winds. There are wind belts called the polar easterlies. These blow from the east. There are other wind belts called the prevailing westerlies, which blow from the west. The prevailing westerlies are what cause weather patterns to generally move from west to east across the United States. The uneven heating of the planet by solar radiation, the Coriolis effect, and the tendency of warm air to rise create patterns of calm areas and wind belts around the globe. Wind is always described as the area it is blowing from, so the easterlies blow from the east, the westerlies blow from the west. The Coriolis effect. Wind currents in the northern hemisphere appear to bend to the right. Wind currents in the southern hemisphere appear to spin to the left. Coriolis effect is caused by the spinning of the Earth, and it's an apparent effect. It's because of the movement of the Earth. Sometimes winds are described as maritime or continental. A maritime wind is blowing from the ocean. A continental wind is blowing from an area of land. Climate near the coast versus inland. Weather near the coast or near any large body of water tends to be milder than continental areas that are not near water. Continental areas, for example, Missouri in the middle of the United States, will experience greater temperature fluctuation, hotter hots and colder colds, than an area near the coast like coastal California or Delaware. We talked about that in the oceans unit. So areas in the middle of the country is going to be colder during the winter and hotter during the summer. But if you're near the ocean or you're near the Great Lakes, you're going to have a milder climate. About 10 kilometers above the surface of the Earth are bands of high-speed winds called jet streams. Local winds. Locally, wind follows the same rules as globally. Warm air tends to rise, and wind blows from high to low pressure. Sea breeze and land breeze. Sea breeze and land breeze are local wind phenomena. They both happen because water has a greater specific heat than land. Water stores heat more efficiently. Sea breeze happens during the day. The land heats up, creating warm, rising air above the land, that's low pressure, and wind blows in from the water to replace that rising air. Sea breeze blows in from the sea. Land breeze happens at night. The land cools off while the water retains its heat. Air above the water begins to rise, creating low pressure. Wind blows out to sea to replace the rising air. Land breeze blows out from the land. Rain shadow. As wind approaches a mountain range, the mountain range will cause the air to rise. Rising air will release its moisture as it cools, resulting in cloud formation and precipitation. On the other side of the mountain, the air sinks, so there's often no rain on this other side. This is called the rain shadow. So on the windward side of the mountain, you get rain. On the leeward side, you get the rain shadow and no rain. Here's a diagram of common cloud types, of which you should know a few. Cloud formation. Certain conditions are necessary for cloud formation. Temperature must be at or below the dew point, that's 100% humidity, and condensation nuclei must be present, some kind of dust in the atmosphere for the water to condense on. This often happens at a front where warm, moist air rises. As the air rises, it cools to a temperature below the dew point. Water condenses on the nuclei, forming the clouds. Clouds are associated with low pressure because air is rising. It's a spooky James River, looks like. Clouds near the ground are called fog or mist. Fog or mist often forms near a body of water. This also requires high humidity, which can be achieved through evaporation. Cloud types. Cumulus clouds are your kind of standard puffy clouds. Cumulonimbus clouds are tall cumulus clouds that indicate thunderstorms. Sometimes you get this anvil shape in a cumulonimbus cloud. Cirrus clouds are the high, wispy clouds. And then you've got stratus clouds that form a layer. The names can be combined when the clouds have features of more than one type, like nimbostratus, stratocumulus, cirrostratus, etc. Mid-level clouds use the prefix alto, so altostratus or altocumulus. Here's a different diagram of a bunch of cloud types. Cumulus, cumulonimbus, cirrus, and stratus are the main types. Lightning and thunder. So oftentimes students are curious about what causes these things. In a cloud, you have air, water, and ice particles bumping into each other, and this friction causes a buildup of static electricity. This static electricity leads to an electric discharge called lightning. Thunder is caused by the rapid expansion of air surrounding the path of the lightning bolt. And that's it for the wind and cloud notes. You can pause the video here and catch up. You can use my fill in the blank option, handwrite the notes, or type them up in your notebook. Bye-bye.